Hey, welcome to The Explainer. We talk a lot about AI, but today we're going to get to the absolute core of it, the single idea that powers so much of the tech we use every single day. We're talking about intelligent agents. Let's dive in.
Okay, so let me just throw a question out there for you. Think about a self-driving car, right? Navigating a super busy street. Or maybe a Roomba, zipping around your apartment cleaning up. Or even just asking Siri a question. I mean, on the surface, these things feel totally different, don't they? But what's the one thing that actually ties them all together?
Well, the answer is, at their core, they're all intelligent agents. Yep, this one single, really powerful concept is like the fundamental Lego brick for a massive range of AI systems. So here's what we're going to cover. We'll kick things off with what an AI agent actually is. Then we'll look at how it perceives and acts. We'll talk about the agent's world, how we design them to be rational, and how they get smarter. And finally, we'll wrap up with why any of this really matters. All right, let's jump right in. What even is an AI agent? Well, think of it this way. AI is all about creating these doers, and that's what an agent is. Okay, the official definition can sound a little academic, but trust me, it's pretty straightforward. An intelligent agent is basically just an autonomous thing, meaning it does its own thing, right? And it perceives its environment using sensors, and then it acts on that environment to hit a specific goal. It's really just a simple loop. Sense, think, act. That's it. So let's dig a little deeper into that core loop, that perceive and act cycle. Because this is the engine that drives every single agent, from the most basic thermostat in your house to the most advanced robot you can imagine. It really all boils down to three simple steps. First, the agent perceives the world around it. It uses its sensors to gather info. That's its input. Step 2, it thinks. It takes all that information and, based on its programming, it figures out what to do next. And finally, step 3, it acts. It uses its tools to actually do something in the environment. And this loop just keeps going over and over, constantly updating, constantly responding. So what are these sensors and actuators really? The easiest way to think about them is to just think about our own bodies. We have sensors, right? Our eyes, our ears, that's how we perceive the world. An AI agent has things like cameras or microphones. And then we have actuators, our hands, our legs. That's how we act on the world. Well, an agent has things like motors or speakers. See? Same idea. But of course, an agent isn't just floating in a vacuum. You can't really understand the agent without understanding the world it lives in. And in AI, designers call this the environment. The environment is really just everything outside the agent that it can sense and interact with. So for a self-driving car, the environment is the road, its other cars, its pedestrians. For a software agent, it might just be a database or the internet. The key thing to get is that defining this world is just as critical as designing the agent itself. They're two sides of the same coin. Let's make this super concrete with a classic AI example, the vacuum cleaner agent. Okay, picture this. Its entire world, its whole environment is just two rooms, A and B. That's it. Its perceptions are really simple. Where am I right now, and is there any dirt here? Its actions are just as simple. Move left, move right, or suck up the dirt. And its goal? Make sure both rooms are clean. This little model, as basic as it is, perfectly shows you that core relationship between any agent and its environment. Okay, so now we have an agent. It can see its world, it can act in its world, but how do we make sure it does a good job? How does it know the right thing to do? This brings us to a really important idea in AI, rationality. Now here's where the idea of being rational gets really important. The formal quote sounds a bit dense, but what it's really saying is that a rational agent is designed to always pick the action that it expects will give it the best possible outcome, the highest score. In other words, it's about always doing the right thing based on what it currently knows to achieve its goal. So to design one of these rational agents, developers use this really handy framework called PEAS, P-E-A-S. It stands for Performance Measure, Environment, Actuators, and Sensors. It's basically a checklist for defining the agent's entire job. What's success look like, where's it working, and what tools does it have to see and act with. Let's run our self-driving car through this. The performance measure isn't just about getting there fast. It's about safety, comfort, and, not breaking the law. The environment is the messy, unpredictable world of roads, other drivers, and pedestrians. Its actuators are the steering wheel, the gas pedal, the brakes, and its sensors are the cameras, GPS, and all that good stuff. Laying out the task with PES is really the first crucial step to building any AI that works. Okay, so once we have this framework, we can start to see how not all agents are built the same. They can range from incredibly simple to, well, almost unbelievably complex. And it all depends on how they think. On the most basic level, you've got what are called simple reflex agents. These guys operate on super simple if this, then that rules. If the car in front of me brakes, then I brake. They have zero memory of the past. But a step up from that is the model-based reflex agent. Now, this agent actually keeps an internal model, kind of like a memory, of how the world works. It can track things it can't even see right now, which lets it handle much more complex situations. And it gets even more sophisticated from there. You have goal-based agents which don't just react to the moment. They have long-term goals and can actually plan a sequence of actions to get there, like a GPS figuring out the best route to your destination. And then even smarter are utility-based agents. They're designed to weigh different possible outcomes to maximize their utility. You can think of it as a measure of happiness. This is absolutely crucial when you're dealing with uncertainty or goals that might conflict with each other. So, wow, we've covered a lot of ground here, right? From simple perception all the way to complex utility functions. But why does understanding all this agent framework, why is it so important? What's the real take-home message here? Here it is. The most crucial takeaway is this. Thinking in terms of agents and their environments is the absolute foundation of how we design modern AI. I mean, it doesn't matter if it's a simple bot in a video game or a rover exploring another planet. It all starts here. You define the agent, you define its world, you define its goals, and you define how it measures success. This framework is what lets us build systems that can act intelligently and purposefully in our world. And that leaves us with a final and pretty fascinating question to think about. We've talked about designing agents to be perfectly rational, to do the best possible thing to achieve their goals. But what happens if the goal we give an agent isn't quite right? What happens when a perfectly rational system starts pursuing a goal that doesn't fully align with our human values? That right there is one of the biggest challenges AI developers are wrestling with today. Thanks for watching.